Hey there, guys. We have Jared Parsons here, C# compiler team lead, and Yuri Kirbitskov, a person who spent a lot of time working on C# stuff from different fields like industrial systems and large enterprises in banking and business processes with credits and loans. So nowadays he works on organizing .NET meetups in Kazan. Hello, Yuri. So I've seen this I guess you've seen too, like this wonderful video where we've seen that Jared actually talks to us from Kirkland. So it's good morning, right, for you?
Yes, good morning. It's about 8 a.m. in the morning here.
Oh my God. At what time did you wake up actually, so to be ready to talk?
I woke up, I had plans to wake up at about 4 a.m. so that I could kind of get up, get in the right mind space, but I also have a 2-year-old daughter, and she told me that we were waking up at about 3:30 this morning.
Okay, nice. So you had like more time to like build your mind.
Yes, I did.
Yeah, so let's talk about something else which is written in my list about you. So it's written that you have a strong passion for developer tools, Jared. Would you tell us what kind of tool is your favorite one?
So my favorite tool is definitely Vim. So I'm a lifelong Vim addict, to the point where you're going to see in my talk when I'm editing code that if you're familiar with Vim, you'll see the familiar block cursor and a lot of the kind of motions. That's actually a plugin to Visual Studio called VS Vim that I wrote so that I could really kind of fill my Vim addiction in the IDE that I use the most.
Let me ask you one more question. Maybe you're just doing all this stuff just because you can't exit Vim. I'm sorry. I'm sorry.
That's the only reason. I've tried to quit programming languages for 15 years. I can't get out of them, and they just won't let me leave.
Yeah, okay. So, Yuri, what about your favorite tool?
Well, once I left Vim, that's why I am now using Visual Studio. I'm a fan of Microsoft, and the Visual Studio with code, one of the best tools to my mind.
Yeah, thank you. So let's take a look at this Vim VS Studio. Let's go to the talk. Jared, good luck.
All right. So thank you, everyone, for attending my talk today. So I'm here to talk to you about nullability in C#. So first off, a little bit about myself. So as I said, I'm a member of the C# compiler and language design team. I've been working in the C# production team for about 7 years now. Overall, though, I've been at Microsoft working in programming languages for about 15 years in various places. And so I'm very passionate about programming languages, and I'm really excited to talk to you about nullability kind of after all the time we spent getting this into the language. So this talk is kind of broken down into a couple sections. So first off, we're going to talk kind of about the design inspiration for this feature and how we arrived here. Then the middle of the talk is going to be very demo-based. We're going to go through the base feature set for nullable reference types, and then through a lot of the additions that we add in C#9. And we'll kind of finish up talking about some adoption strategies and what we can look forward to for nullability in C#10 in the future. So we're going to start with kind of the design process of nullable reference types. So null safety in C# is something that customers have been asking us for about the last decade, and it's something we really wanted to give them. But how do we get from this idea of null safety to an actual feature? And I think kind of understanding the scenarios and kind of the motivations behind the features will really give you kind of a better insight into it and help you with key your intuition on how it should work in your programs. So the starting point for our journey is C# 7.3. And that version of the language has no null reference support. Instead, developers are just following best practice. They're using kind of an established set of patterns and methods for handling null values. They're probably spending a bit of time reading API documentation, maybe adding a bunch of guards for APIs they're unsure of. And we want to fix this. C# wants to change this. But how do you add nullable tracking to a 20-year-old language? And how do you maintain compatibility while doing so? And continue to support this diverse ecosystem of libraries. And one important distinction here is that we are extending a language. We are not creating a new one. When you're creating a new language, you have unlimited possibilities. You could do something like F#, where they embed null deeply into the type system. And then they add all of these features to support it, like match expressions and discriminated unions, that really make that feature shine and very easy to use. With C#, though, we're extending a language, and that really narrows our possibilities. There are 20 years of features that were designed that never thought about nullability. And C# developers, they use kind of a standard set of practices and helpers for dealing with null. And that really contributes to the look and feel of the language. And if we pick a much more invasive solution, we risk kind of creating something that's unpalatable and just unfamiliar to developers. And I want to go through a couple of those more invasive solutions that we looked at and kind of why we discarded them. So the first is what about creating a perfect type solution? And by perfect, I mean something where you completely separate nullable and non-nullable types to the point that if you have a non-nullable type, you are guaranteed at runtime that that will not be null. If you actually dig into the history of C# a bit, you will find that there are several variants that did exactly this. The most popular of which is probably the SpecSharp project, which was done by Microsoft Research. That was a very well done project. And if you look at all of these variants, you will see that they mostly achieved their goal of perfect null safety, but they had very little adoption, like publicly or internally. And the reason for that was the language they ended up with wasn't really C# anymore. And that's because there are a lot of features in C# which they kind of fly in the face of perfect null safety. So array creation defaults to putting nulls in the elements. Calling methods or properties in a constructor, that can subvert field initialization. Using default of T in generics creates nulls. And if your goal, and these are features developers take for granted and they love them. And if your goal is perfect null safety, you kind of have to get rid of them. And so that meant while these languages were successful at creating a perfect null safety, they just weren't C# anymore. And developers didn't adopt them. Another suggestion we often hear is what about an API solution? So optional of T. Think about this as nullable of T, but for reference types. And it has all the advantages of nullable of T. You can't use nulls directly. You have to use a nice get, check for the value and then use the value. And as a bonus, this solution, it doesn't require any language support. So you don't have to wait for my team to, design, code, and deliver a feature. You can start on this today. The problem, though, is this does nothing for existing code. You have to move to a new set of, you have to take all of your existing checks and move them to a new set of checks. And further, every time you go and change your string question to your string into an optional string, you just broke binary compatibility if that's a parameter. And that limits the set of customers who could use the feature. And worse off is, this is yet another form of runtime null that you're adding to this problem of null. And so overall, this was a solution that we kind of just moved past. So another thing we really had to consider is there's a lot of C# code to annotate out there. Code bases come in a lot of different sizes, from small code bases, which are less than 10,000 lines of code, up to the jumbo code bases about above 1 million. And these large and jumbo code bases, they're more common than you might expect. If you look at the .NET organization on GitHub, you'll find that the Roslyn and Runtime repo, they're both above 5 million lines of code. ASP.NET Core is a little over 1 million. And these kind of larger repos, they're not just something that only Microsoft does. We've seen kind of the same distribution of code sizes inside Microsoft and in the customers we work with. And the thing is that null safety must be usable in all of these code bases. And that tells us kind of something right from the start. We can't design a feature where we kind of require null safety to be turned on all at once in a code base. And that's because the cost of adopting nullability is going to be proportional to the size of the code base that you're applying it to. If you have more code, you have to add more annotations. And that means for large code bases to enable nullability, you can end up changing thousands of files. And I want you to think about that. That means you're sending a pull request to GitHub that has many thousands of files. I'm not sure if you've done that before. I've done that several times. And so I can tell you some about the experience. The first off is GitHub won't display that very well. GitHub starts limiting features at about 100 files. Once you get to about 1,000, they really start limiting features. If they'll display the pull request at all, it's possible that you might get to see the unicorn guy. And as I said, I've sent many 1,000-file pull requests, so the unicorn and I, we're good buddies. We've seen each other a few times. And kind of on the other side of it, you're creating a lot of work for your coworkers. Even like a 50-file pull request is a lot to review. When you send 1,000, you're creating a lot of work, and your coworkers aren't going to be very happy with you about reviewing that. Again, I've tried it. They've given me feedback. And so that really tells us that in order to be successful, we have to support incremental adoption with this feature. Developers must be able to annotate a single component, a file, a directory, so that they can keep these PRs manageable and focused. And lastly, we really have to consider that .NET has a broad ecosystem. Like NuGet.org alone has almost 200,000 packages. And if you start thinking about private companies and solutions like MyGet.org, there's probably an order of magnitude more libraries out there that we're just not even aware of. And we can't sit down there and believe that we're going to release this null safety feature, and then a day or two later, all of these libraries are suddenly going to become annotated. That's just not realistic. It's going to take time for a feature to flow through the ecosystem, whether it be nullability or anything else we release. And the thing is, developers, they can't wait for the ecosystem to get null annotations. When we release this feature, they're going to want to use it immediately. And that means that we have to design this feature so that developers can use it on day one. They can turn it on in their code. They get value, and it adds safety to their solution, even if none of their dependencies have turned on null annotations. That's really important. And so we can kind of step back now and say, like, what are the principles for this null safety feature that we're going to create? And the first is we have to embrace an imperfect solution. C# has 20 years of features that just weren't designed for nullability, yet they're used and loved by our developers. We have to kind of embrace them in the solution that we create here. And we can't just ask them to throw that away in order to get null safety. And also, we must add value to existing code without a major rewrite. C# has like a very standard set of practices for how to deal with null. And we have to find a way to make those better. We can't tell customers to throw that all away, move to a new set of patterns and a new set of types. And also, we need to provide nullable guidance through warnings. Developers need to feel free to annotate their code with the knowledge that it's not going to impact runtime or semantic behavior. It's just going to give them better information about the null checks that they've already written. And lastly, as we talked about, we need to support incremental adoption here. So with that said, we're going to move on to kind of the demo phase of this talk, our non-nullable reference types, aka also known as the last 3 years of the C# team. And when I say that, I'm quite serious. This was actually the nullable reference types is the biggest feature that the C# team has done since generics. It took us an enormous amount of time, and so we are even that much more happy that it's released and we can give it to customers. All right, so now we're going to flip over here. And so one thing to point out, I know that the solution structure on the right is a little bit small. It's not important to see the solution here. This is all going to be about the code that I'm showing. So the first thing we're going to talk about is how to enable nullable reference types. So there's two ways to do this. The first is doing it at the project level. And so enabling it for everything in a project. And the way to do that is just open up your project file, use the MSBuild nullable property, and just set it to enable. And like I said, this will enable it for everything in a project or a solution if you use dir.props files. And this is where a lot of people end up when they have majority of annotations. But for the purpose of this talk, we're going to use the more fine-grained incremental annotation way because it's a lot better to demo some of these features. So the more fine-grained annotation way is using what we call the nullable directive. So it's just nullable, enable. And much like Pragma, what this does is it says, it's a lexical directive that says, anywhere below this point in the file, please give me nullable warnings and metadata. And so you'll see immediately that the compiler has started giving me feedback on the code here. When I hover over here, it's going to tell us that, hey, this this field ID is marked as a non-nullable type, but the type widget doesn't have a constructor. That means when people create instances of this, you're going to have nulls. You've broken your contract. And we can quickly fix this in the description one by turning this into a nullable string by adding the question mark here. And you can see the compiler immediately removes the warnings. And as we scroll down here, you'll see the compiler is once again giving me some very valuable feedback. It's saying, hey, you're passing a non-null widget to try to get value. That can return nulls. This looks like a problem. And once again, the compiler is right. And we can fix this by making this a nullable widget type. But then we get to the bottom here and we say the compiler is warned us again. It says, hey, this method is returning a non-null widget, but you're returning a nullable widget. This is a bug. And the compiler has indeed spotted a bug in this program. There's actually a couple of missing cases here in the switch where widget's not initialized, and the compiler is giving me great feedback here. You have a bug. And so just by adding this little annotation, you already start to get value, no matter what kind of code you're working on. Now, I want to take a minute and start talking about how annotations kind of interact with each other. So as you can see here, we have two methods, disallow null and allow null. Disallow null takes a non-nullable string, and allow null takes a nullable string. And we have this method example, which has a non-nullable string. And you'll see that we get the kind of feedback we would expect. We can pass it to any method. We can invoke members on it with no warnings. The moment we try to assign null to it, the compiler says, hey, that's a problem. You should not be able to assign null to a non-nullable string. Now, let's switch this to a nullable string and see what happens. Notice that the warnings immediately change. The compiler is now telling us, like, hey, you're passing a potentially null value to a non-nullable. That's a problem. Now, an astute observer might notice, like, hey, why isn't the compiler giving you a warning? Like, this is a potentially null value, and you're invoking a method. Well, what's going on here is the compiler is saying, I already warned them once about str. I don't want to just kind of flood the editor with warnings. So generally, it's only going to warn you the first time you create a null reference. And we can see that here by, if we just comment this out and say, okay, we didn't make that line of code, immediately the compiler says, okay, here's the first null reference of that type. Now, as we said, this is an imperfect solution. There are going to be places where the compiler has the wrong analysis. And so we wanted to make it easy for developers to kind of override the compiler and say, hey, no, trust me, I know what I'm doing here. And the way you can do that is with what we call the null forgiveness operator. Essentially, you can add an exclamation point to the end of any expression, and then the compiler will just say, okay, that's non-null, I believe you. I will trust you here. I actually applied to have this be called the trust me operator. I was shot down, they kept it as null forgiveness. So now, let's take a look at what happens when we start mixing nullable annotations and generics. So you'll see here, we have a list of non-nullable strings, and we get kind of the feedback, once again, that we'd expect. If we try to assign null into the list, we get a warning, and that's about it. Now, though, let's flip this into a list of nullable strings. Once again, the warnings flip on me. It's now okay to assign null, but I'm going to get a warning if I try to invoke any members on these elements. And I'm also going to get a warning if I attempt to pass them to disallow null. And lastly, the compiler is warning me that, hey, this object creation expression is wrong. And the compiler is saying that you're mixing a list of string question with a list of string. And the compiler is right. Like, this is conceptually no different than trying to assign a list of int to a list of int question marks. But once again, we can just fix that by having the types line up. I think the other thing to kind of talk about annotations is I talked a lot earlier about the ecosystem and having to be successful when you were dealing with code that wasn't annotated. And so we can actually observe how that works here by just taking this lexical directive and just moving it down a few lines. And so now what is happening is below this point in the code, I have null annotations enabled, but above it, I don't. And using this code is no different than using a library that has never seen nullability. And as you'll see here, a couple of the warnings have now just gone away. So I'm no longer getting warnings when I call disallow null, but pass potentially null values. And the reason why is the compiler, when you call into code that doesn't have annotations enabled, the compiler just trusts that you're doing the right thing. And that's because it has nothing else to go on. There's no annotations there to tell the compiler, is it right or wrong? So the compiler just says, we will trust the user here. And at some point in the future, when this code gets annotated, we will be able to give the user the correct feedback. Now, annotations are great because they let an API accurately kind of express, like, what is my contract? I accept null, I return null, or I don't on either of those. But annotations are not enough to have a good solution here. And I think we can use this demo, this little function is a great way to demonstrate where they kind of fall short. So we have a method getUserData. The idea is it takes an optional ID, it grabs the user for that ID and returns it. If you pass it null, we'll just grab the default ID for the user and return that instead. And because this is potentially null, we make this as, we have to mark this as a nullable string. But then you'll notice here at the bottom, I'm having to use the null forgiveness operator. And that's because, once again, the indexer for dictionary takes a non-nullable string, but I'm passing a nullable string. And as we showed on the previous slide, that's kind of a mismatch, and that should be a warning. But this is an extremely common pattern. And having to use null forgiveness here really kind of devalues the compiler because you're just turning off null checking in so many places. Let's see what happens, though, if I delete this operator and just use it naturally. Notice that the compiler doesn't give me a warning. And the reason why is because even though string is marked as nullable, the compiler, the ID here is marked as nullable. By the time the compiler gets this line of code, it knows that this value can't be null. And that's because the compiler is using a feature called flow analysis. It's looking at the flow of the values through the program and understanding the null state of identifiers kind of at this point. And it can see that, hey, in the case that ID is null, we assign it a non-null value, so we're fine here. And now let's play with this feature a bit to see what all it can do for us. So you'll see if I do like id.toString here, gotta paste it correctly, the compiler gives me a warning because it says, hey, at this point in the program, ID is still null. And now, if I move it below that assignment, the warning goes away because the compiler knows this is safe, it is non-null. And even if we open up an else block here, and once again we say id.toString, the compiler is once again, it's not going to give us a warning because on the else block here, the compiler can tell this is not null. Lastly, though, let's see what happens if we just assign it to null in the else block. Now the compiler starts warning us here on the use of ID in the map because we're passing a potentially null value into something which can't accept null. Now, this flow analysis is not just limited to locals. It actually can go to fields and properties as well. And we can see that if we, instead of returning, we store this user in a local, and we say like, hey, user.fullname, get hash code, get enumerator, that's fine too. You'll see, because up here, this is a nullable string, the compiler is warning us this might be null. But if we just add a simple, check here, you'll see the compiler removes the warning. Because once again, it can tell by this point in the program, this can't be null. And this is really important because this is the type of code that users write. These are the standard set of null practices that developers use every day. And the compiler is able to learn from them and design the experience around it and give them the right null information. And what's better is this feature, this flow analysis, it's not just limited to if and else. It is actually deeply embedded into kind of every control flow structure we have in the compiler. And I think one of the best ways to demonstrate the power of this is with kind of a switch statement. So you'll see here, we have a little function called printIsNumber, and it does all kinds of incorrect ways of turning an object into a number. And it's an object question mark because it accepts null values. And so you can see here, first off, we switch on this, and then we have caseString. Now look what happens within caseString if I basically call a method on data. Notice that the compiler doesn't give me a warning because the compiler can tell that in order to get to this label, object was a string, which meant it's non-null. And so I can freely use data here without having to do any kind of forgiveness operators or assertions. Now, contrarily, look at case_var. So for those unfamiliar with case_var, this is very much like the default case. It will match any value. And the compiler can tell, like, hey, data could be null. That means this null could be matched. And so this is a potential null reference exception. Now, let's look what happens when we choose to handle null with an explicit case. notice that the warning goes away down here because the compiler can follow that null and say that, oh, that null is handled in a different case. By the time we get here, this can't be null. It's not a possible input. And even better, if you look at the kind of end of the method here, we have a call to data.toString, which is still warning this could be null. Well, let's change this break into a return. Notice this warning goes away because once again, the compiler can follow that null, see where it never can reach the end of the method and know that at this point, data is not null. And so this flow analysis tool is really powerful and it really feeds into the way people write code today. Now, I started kind of the last section was saying, annotations are great, but they're not good enough. We need flow analysis. Well, now I'm going to say flow analysis is great, but it's not enough. We need something else. And the reason why is flow analysis is great at looking inside a single method, understanding how the code flows, and kind of adapting the warnings to it. But think about all the other things that you do to check with null, all the methods you use that help with null. So like your debug.asserts, your throw if nulls, or your kind of try get values. These are all methods which essentially add information to the null state of the program and the values. However, they're just method calls. The compiler can't tell the difference between a call to throw if null and console.writeLine. They're two methods, they take a value. Who knows how they influence the null state of the program? But it's also really important that the compiler does understand these methods because they are central to how null checking works in C# code. Like when we looked at our code at Microsoft, we found these helpers everywhere. And if we didn't find a way to connect the dots for the compiler, this feature was just going to be incomplete and just not be usable in real world scenarios. And so a good example of that is here. We have an assert method, it takes a Boolean. In the case that is false, we throw an exception. And so then we basically add an assert up here and say, hey, assert address is not null, and then we use address below. So as a programmer, I know that this is safe. Like this is going to throw if that is, a null. And so I can safely use address here. But the compiler is warning me because the compiler can't connect the dots between that null check and the flow of the program. And what we did in C# to let the compiler connect those dots is we added a series of attributes that customers can add to help the compiler understand what's going on. So here we can say, does not return if this value is false. So immediately you can see that the warning goes away because now the compiler can understand how this null check impacts how the assert method runs. It knows that, hey, if this is false, that method's not going to return. Therefore, if I get here, address is non-null. And so once again, the user hasn't changed how they wrote the code. All they've done is just give the compiler a little bit of a hint on how it works. And these attributes, like I said, we added a whole host of them. And another popular pattern that we added them for is the try patterns. So your try parses, your try gets. And we have a method here that essentially it has a bit of text, it tries to parse it out to an address, if it fails, it leaves, and then it kind of uses that address later on. And once again, as a developer, I know this code works. I know this code is null safe, but the compiler is giving me warnings. And once again, we can help the compiler out here because we can say that this address value is not null when this method returns true. And so we add this attribute here. Oh, I used the wrong one, not null. Use not null when. And you can see immediately the warning goes away because once again, we've been able to connect the dots for the developer, for the compiler. And just to show you it's not like a fun demo trick or whatever, when we move this to false, you can see immediately the warning comes back because the compiler can now trace the value in the other direction and say, hey, this can definitely be null here. Now, so this is basically the feature set that we gave developers in C# 8. And so now we're going to switch gears and we're going to start talking about what all did we add to this in C# 9 and why did we add it? So the first one we're going to talk about is when we released C# 8, one piece of feedback we kept getting from customers was, hey, there's a pattern in my code where one member of my type, one of these methods or properties, it will tell me something about the null state of a different member in that type. And kind of the most popular iteration of that pattern is what we call the has value value problem. And so that's demonstrated by this little result type here. So result, it has a value, it's potentially null. And then it has like this has value method, which kind of tells the developer, hey, this is not null. Sometimes it was simple as a null check. Sometimes it was a much more complicated check that kind of prevented you from using values safely. But for the demo purposes, we used a nice simple check here. And you can see like this is the type of code that users wrote. If has value, then use value. And once again, they know, as a developer, this is safe. This will not be null. But the compiler is giving me feedback here that it could be. So in C# 9, we added a new attribute, and it's called member not null. And we have the two varieties, the unconditional and the conditional. So we have member not null when true. When this has value returns true, then the value member is non-null. And you can see immediately the warning has gone away. We have once again allowed the developers to continue writing the code the way they want to write it. And we are just kind of helping connect the dots for the compiler there. And you can see, as again, like this is not some kind of like slick trick. If we go down here and we try to use by toString, the compiler is going to tell me that this is wrong and we have a problem. So the other form that this kind of feature came in terms of members that impact the null state of other members is what we call like the init pattern. Customers sent us endless amounts of types where they had a method called init or ensure initialize. And the idea was there were a lot of fields and properties that got initialized in a common method. And so when you looked at the fields themselves, you would say, hey, these are null, but the init method was the one that was responsible for making them all not null. And the kind of standard pattern you would have is right here. Like you create a new instance of the type, eventually you call this method ensure initialize, and then you should be able to safely use those values. But once again, we gave really no help for that in C# 8. So this is another place where we can leverage member not null. So we can basically say member not null, property 1. And so parent 1 guarantees it will initialize property 1 and it's ensure initialize. And in this override here, child will initialize property 2. And so you see up here, again, the warnings are gone. We've connected the dots for the compiler. There are a couple of interesting things to note, though, about this one. And one of them is notice that we're calling child.ensure initialized here. But the compiler has removed the warnings for both of the properties. And that's because for this attribute and some of the others, the compiler is now looking, when you give it a virtual chain of methods, it looks at every method in that set of virtuals and essentially does the union of all of the nullable contracts you had. So here, even though we're calling child.ensure initialize, the compiler sees all of these contracts, it puts them together and gives the developer the experience they want. So something else about attributes that we changed in C# 9 comes down to enforcement. So in C# 8, when we gave developers attributes, it was all kind of on an honor system. We said, hey, we have these cool attributes, not null, does not return, have fun. And developers annotated their code. And for the most part, they did the right thing. They added contracts in the right places and they had the right guarantees. But then we kept finding places where customers were sending us reports where they had added contracts that were incorrect. They basically said things were not null, but if you actually looked at their code, like they could be null, or they had methods that did return. And so this was in some ways devaluing the feature because even though customers annotated the code, we weren't giving them help to understand that those annotations were correct. So starting in C# 9, we said, okay, when we add these new attributes, we are going to add enforcement for them. And so you can see that with kind of member not null here. So if I go in here and let's look what happens when I comment out property 1 assignment. Immediately, I start getting feedback from the compiler. Hey, member not 1, you promised that property 1 would be non-null, but you never assigned it here. And so the compiler is holding me accountable for the contracts that I added in my code. Even better, like if you go down here and remove this based on ensure initialize, once again, the compiler is going to call you out and say, hey, even though I'm looking at the total contract here, the union of all these contracts, and that includes property 1, and you did not assign it, therefore you are not living up to this contract. And so we're really happy to give this to customers because this actually spotted a number of bugs in our own code. And the better is, while we said that going forward, when we add attributes, we are going to add enforcement, We've also gone back to some of the attributes we had in C# 8 in added enforcement for them. So for instance, like we have a little method here called ensure initialize. And so this essentially takes a value and a ref, and it says like, hey, if this address isn't initialized, we will initialize it using the kind of contents of this string. And so, so the contract of this method is this will be not null when this method is done. And you can see this method has a bug. In the case where the value is being initialized and it's in the wrong format, we return without initializing the address. And the compiler is calling us out here. The compiler is saying, hey, address must be non-null when you leave this method. Like that was the promise you made. And further, we have another, like if you look at does not return. So we have this does not return method. It takes a reason. And if that reason is non-null, then we kind of throw an exception. But then we call to this other method that is not marked as does not return. And so this could indeed actually return and change the behavior of the program. And so once again, though, if we look at the compiler, it is warning us saying, hey, this method is marked as does not return, but it is actually returning. And so once again, we need to go through and fix this up. Now, this might seem like these examples might seem contrived, and they are. This is a demo, so we have nice contrived examples. But these are also actually real examples that we got from customers and the .NET Framework code base. And so these are, we feel like this is going to add a lot of values and help push customers to the right place with their null checking. So probably the biggest change we made in C# 9, though, is around generics. In C# 8, as we kind of showed earlier when we were talking about annotations, consuming generics with nullable safety is it's intuitive. You get the behavior that you should get if you're familiar with generics. If you have a collection of nullable strings and you pull them out, it's a potentially nullable value. If it's non-nullable, you get a non-nullable one. The problem we had in C# 8, though, was we made defining these generics a little bit difficult. And that's because in C# 8, you could not annotate a type parameter. You could not say, hey, I have an unconstrained type parameter t, and I'm going to have t question mark. And that really kind of broke your mental model. If you were coming from non-generic code, you would just make a string nullable by adding a string question mark. You couldn't apply that knowledge to generics because we didn't give it to you. Instead, we gave you two attributes. Allow null, saying I can assign null to this type parameter, or maybe null, which means when I return this to you, it might be null. And so let's see how that kind of plays out in a generic collection. So this is collection of t, similar to list of t, but written out here as to kind of help explain how this works. So first off, you're going to see we have this contain method, and it says I accept null values no matter what the type parameter is. And already, like, it's a little bit jarring. You have this attribute here, which is kind of a part of the type system now. And worse, it looks even more jarring because it's right next to another parameter, which is actually using null annotations. So already right off the bat, it's a little bit kind of, not the best experience. Then we have the find method. And find is a method which basically takes a predicate, runs it over every element in the collection, and the first one that matches, it returns it. If nothing matches, it returns default. So this could potentially return null. So once again, we have to resort to an attribute saying, hey, this might return null. But when we start looking at the implementation, though, we see like the next level of problem. The locals I'm creating can also have null in them, but you can't put attributes on locals. And that means there's no way to accurately express the contract of found here. The only thing I can do is basically use the null forgiveness operator and tell the compiler, trust me, I will be good with found, I promise. Like there's nothing else to do. And that's really unfortunate. And the worst one, though, is let's think about the find async version. So just the async version of find, where I have a predicate that returns a task of bool instead of a bool. Well, now I can't put attributes on type arguments. And that means I can't express that this returns null. I can't express that this is a potentially null returning. And in C# 8, there was no answer here. You were stuck. So in C# 9, though, what we've done is we've done all the work to make it so type parameters can have null annotations. And so let's look at like how that impacts, like how that makes this collection much easier and much more intuitive to define. So first, we're just going to get rid of this attribute and say t question. And this is what you would expect. If you're coming from non-generic code, this is what you would expect to write when using type parameters. And it just works. Now down here, we can get rid of this like awkward little return. We can say key question like we would like to. Even better though, I can now accurately express the contract of my local. I can say key question mark found equals default. And the compiler is now giving me the right feedback on it. Lastly, even better, I can finally express the contract of find async. I can go in here and say, hey, this is a potentially null returning T. And so we're really happy to be giving this to customers. Like we've already, ingested this in our own code base and are extremely happy with it, and we know customers are going to be too. Now, some of you may have been looking at that and asking yourselves, like, okay, fine, great. C#9, I can use T-question, all my generics are going to be better, and I'm happy about that, but damn it, I shipped a bunch of interfaces in C#8, and it used these attributes. Like, what's going to happen, if I start switching to use the question marks? Am I going to break all of my customers who aren't using them yet? And so I want to take you back kind of to the beginning of this talk, where we talked about our focus on a mixed ecosystem and understanding that nullability just won't show up everywhere at once. It's going to come in waves, and it's going to come at different times. We really took that to heart when we did nullable reference types, and we kept that in mind when we made this change, such that you can now freely mix attributes and non-attributes in your type definitions. You can see I removed the attribute here, I switched to a question mark, and everything still works. Further, you can do it in both directions. You can remove the attributes here, put the question marks, and once again, you'll see that the hookup still works. So once again, if this is exciting to you and you want to use it, just use it. You don't have to worry about the impact this is going to have on anyone who's taken a dependency on you. And once again, just to show you that there's no tricks here, if we delete this question mark, you're going to see pretty quickly the compiler says, hey, this is wrong. The nullability of left does not match the interface. So we are doing rigorous checking here, but the way we've done it is by kind of saying that allow null T and maybe T are really kind of just the same type as T question mark in our type system. And we've kind of embedded that deeply into our structure here. So the next thing we did a lot of work on was constructors. So the way we did constructors in C#8 was we leveraged definite assignment. And the only rule we had in constructors was whenever you leave a constructor, all fields must be definitely assigned, much like they would be in a struct. And while that worked, it ended up, that works because if you force every field to be assigned, then if someone does something wrong, like assign a null to something which is non-null, you get a warning. And so that worked, and you could define constructors to meet all of your scenarios. However, it had a problem. And the problem is that developers spend a lot more time writing methods than they do writing constructors. And that meant that all the things we've talked about flow analysis and how that works, it set the mental model for developers on this is how nullability should work. It should be flow-based, and I should be able to think about my program this way. Then they got the constructors, and it worked a completely different way. And they ended up sending us a bunch of bug reports, and we're like, no, those are bugs. Like, that's how it works. And that, after enough of those bug reports, we internalized that. Like, that's our fault. We kind of we screwed up the expectations here. And these bug reports came in kind of the following flavors. Like, first off, this line of code caused no warning in C#8. This is a classic null reference. You're using a field before it's assigned. And in C#8, we gave you no warning because the only rule we had here was at the end of the method, first must be assigned. And they did that. So it met our contract. Like worse, like even here we have a constructor that calls out to a helper which initializes the fields based on the data. This is a very common practice. And customers, based on their expectation for methods, thought we can make the compiler understand that by using debug.assert that first and last aren't null here. But once again, the compiler didn't care about flow analysis. It just said these must be definitely assigned. And so it gave us warnings. So we took this to heart in C#9, and we completely rewrote constructors. And we rewrote them to be flow-based. And so now, let's see what happens when we enable nullability in this constructor in C#9. You'll see immediately, we get a warning on that really bad piece of code, the piece of code that every developer, every customer we had thought should warn, and they were right. And we can quickly fix that by putting it down here. And the compilers, once again, it's now still giving us the warning that, hey, you didn't initialize all the fields here, and that's a bug, and we can fix that very easily. And even better, the compiler is respecting because it's flow analysis based, it now respects these assertions. It does not give us any warnings about these fields not being assigned. And so once again, the developers can write the code they wanted to write, and C# is helping them with the null checks. And as always, to show you this isn't kind of a trick, as soon as we remove that assert, we get the warning from the compiler that said, hey, last must be assigned here, and you have a bug. Now for a change like this, one where we vastly change how the data flow works and we deliberately introduce new warnings, those usually make us pretty nervous. Compiler teams are pretty conservative by default. And so for this particular change, we did what we call a full test pass. We added this feature to the compiler. We rebuilt the entire C# code base, the .NET runtime, and all of Visual Studio, and basically said, how did that work? And what we found is, looking at a lot of code, people could undo some of the workarounds that they had done when they encountered C#8. And overall, we actually introduced about 5 warnings into the build on all those 3 code bases. But for each one of those warnings, we looked at the code and we're like, wow, that's a bug. And we emailed the team and said, you guys have a bug and you really need to fix that. And so overall, this change helped people remove some workarounds they'd added in C#8. So removing some of those kind of false positives while adding a small number, but very real warnings into the code. So we were really happy with this change and ended up pushing it in for C#9. So something else we also got a lot of feedback on was local functions. Particularly, we got 2 pieces of feedback about local functions. The first is that you couldn't put any attributes on local functions. And that was by design. When we initially wrote local functions in C#7, we didn't add attributes because when we looked at it, we said, that doesn't add any value. And so as a cost-saving exercise, we just didn't support attributes on local functions. Well, as I've gone over several times in this talk, attributes are pretty key to nullability. And customers called us out really quickly saying, hey, that's a gap and it's causing me problems. And I think a good way to demonstrate that is with this sample here. So we have a method, it takes a potentially set of null lines, runs a regex against them, and if it's not null and matches regex, we feed it to this action delegate. And you can see it's a pretty straightforward bit of code. There are no warnings. Well, let's look what happens when we factor this into a local function. So let's extract there we go. And we're going to call this local function is valid. So what you're going to see here is immediately the compiler gives me a warning. And that's because this null check that we had online is now within the local method. So the compiler can't tell that this is being properly accounted for, and it's giving us a warning. In C#8, that was the end of the ballgame. There was nothing else you could do. The only thing you could do is just add the null forgiveness operator and move on. In C#9, though, we added the support for attributes on local functions. If that means developers can apply the tools in their tool bag that they are already using. And we can say that, yeah, this is not null when this is true. And you'll see immediately the compiler removes that warning because, as we've shown many times before, this attribute just connects it up for the compilers. But now, this really goes a step further at making sure that we keep local functions on par with regular functions, and there's no kind of friction point in using them. The next bit of feedback we got about local functions is about how we captured values. In C#8, when we captured a value, we have to make a decision, what is the null state of person in this local function? And in C#8, we basically said, what's the type? Well, the type here is a nullable person, so we're just going to say person could be null in this local function. And that caused a lot of friction, because much like constructors and the friction we caused there, we had really taught developers that nullability is flow analysis based. And the customers could look at their code, and they could say, look at the flow of this code. If person is null, we initialize it. So by the time we get to print person, this can never be null. And once again, they sent us bug reports. We're like, well, that's how it works. And after a little bit, we internalized. We're like, no, we've set expectations wrong here, and we need to fix that. So we completely rewrote capture in C#9 to be flow-based. And you'll see now, this pattern of code no longer generates a warning. Customers can continue writing the code the way they wrote it, and we will give them the right feedback. And the way that we do this flow analysis capture is we look at all the places this is called, and we basically say, what was the worst state of the variable at all of these places? And so you can see if we just take this method and we just add a call above to print person before we initialize it, immediately the compiler tells us, hey, that's wrong. You call print person before you initialize it. This can be null, and that is a bug. But now it's flow-based, and it should be much more natural. So lastly, I want to talk about one of the best things we've done in .NET 5, which is framework annotations. So at this point, the .NET Core SDK, the core libraries there that you use in pretty much all of your program. In .NET 5, the runtime team has essentially turned on null checking on the entire .NET runtime code base. And in .NET 5, these all come to you in form of API annotations. So whenever you upgrade to .NET 5, you now start getting all of the nullable information that the .NET team has pushed into our libraries. And that is hugely beneficial because it gives you immediate feedback in your program and whether or not you're using null values correctly when talking to the framework. And I think the best way to demonstrate the value of this is with a pop quiz. And I must say from the start, like this is actually a pop quiz that a coworker of mine, Drew Noakes, wrote. And he showed it to me and I loved it so much, he agreed to let me put it in some of my demos. But the pop quiz is, let's look at these calls. All of these path.get file name, get path through. These are all functions which basically take a path, they slice it up, and they give a piece of it back to you. So these don't even touch the file system. These methods, all they do is string manipulation on paths. And so the pop quiz is basically, which one of these return null? And I'm guessing that most people don't have this paged into memory, but I'm sure a lot of you are thinking, well, given that these methods all kind of do the same thing, I would expect that either they all return null or none of them return null, because that would be kind of the sensible thing to do. Well, let's see what happens. Let's turn on nullability and let's just get the answer. And what you see here is there's no consistency. Some of these methods return null and some don't. And there's no pattern. And before we had the annotations of the .NET framework, it's not realistic as a customer that you could have figured this out. And I can tell you that because we were surprised on the .NET team that some of these return null. Like we expected, as soon as we added these annotations, people started finding bugs. Like that can't return null. Like why did you mark it that way? And we had to point out to them, it's like, actually it can. Like look at this code path that we hadn't really thought about. And so before these annotations, you couldn't have gotten this information accurately. But now it's basically free. Turn on nullability and we will tell you when you use it incorrectly. And now you might be asking yourself, we're going to do the opposite version of the quiz. Which ones accept null and which ones don't? And at this point, you might be saying, well, maybe there's some consistencies in the ones that return null and whether or not they accept null. And if you even thought that, you would also be wrong because there's just no consistency. There's no consistency within the inconsistencies. Whether or not these return null or accept null is a series of random decisions made by the individual developers who wrote these APIs. But now you don't have to worry about that. You can just enable nullability and get all of this information for free. So now we're going to switch gears a little bit and we're going to talk about a little bit about adoption strategies in your code. So the first one is what target framework should you use if you're using nullability? And there is a clear answer here. You should be targeting .NET 5 if you can. And the reason why is .NET 5 is the only target framework where we have both all of those attributes included in the core libraries, as well as having the core libraries be fully annotated. And this has kind of been a long journey for us. If you kind of look back at .NET Core 2, we had nothing annotated because we didn't have nullable reference types. On .NET Core 3, we got to about 31%, so about 5,000 to 6,000 of the core library APIs are annotated. But by .NET 5, we are in the high 90s. This slide is a little bit old. We are a little bit further along now. And so basically, if you're using the libraries from the core libraries of .NET 5, they will be annotated. And it is, as I showed in the previous that last demo, it is immensely valuable to your program. Now, one question I get a lot is, well, I write a library that has to target some older framework. I'm targeting Net Standard 2.0 because I need the breadth of distribution. Or I'm targeting NetCore App 3 because that service I deploy to, it just doesn't support .NET 5 yet, so I can't move to .NET 5. And so I can't get these annotations. And they're like, how can we fix this? And my answer is leverage multi-targeting. So change your library to multi-target .NET 5, and .NET Standard 2, or whatever else you're targeting today. And then only enable the nullable warnings on .NET 5. As we said before, kind of started this talk, nullable warnings don't impact semantic or runtime behavior. So this isn't going to change how your program works. It's just going to make your program better by telling you more information about the APIs you're using. And once you've done this multi-targeting, you haven't even lost any of your distribution breadth. Like you're still distributing like a Net Standard 2 library and a Net Core 3 app library. So you can keep using your code everywhere you used to use it. You will just get the full benefit of the null annotations. And setting this up is really easy. Here we have a project file, which is just a standard one, which multi-targets, .NET 5 and Net Standard 2. And the only thing I've changed here is I have a little property group that says, hey, if I'm not targeting .NET 5, can you just turn off the nullable warnings for me? Thank you. Like I said, I highly encourage people to try this if you have a library. This is actually how the compiler itself works. We target Net Standard 2.0 for the breadth of distribution. The compiler runs everywhere. However, we're big fans of nullable reference types, and not just because we spent 3 years writing them. And so we like getting the full value out of them. So for a long time now, we have taken this approach of multi-targeting in our libraries, and we've found it to be immensely beneficial. Now, another question we kind of get a lot is like, what order should I annotate my code in? And there are a lot of different strategies for doing this. And I would say, kind of learn about them, think about your code, and figure out the best way it would work kind of for your solution. Like one of them is the simplest one, annotate everything at once. Once again, though, I would say I would limit that to about 50 files. If you get above that, I would really pick another strategy because otherwise it gets a bit unwieldy after a while. Popular one is component by component. Find the most troublesome component in your system, annotate it, and move to the next one. Or if you have a big solution, think about doing dependency ordering. If you think about your solution as kind of a series of libraries that are a tree and they depend on each other, annotate the root library first, move to the next level of the tree, annotate all of them, and just kind of move down in dependency order. And what that helps is if you do it in the opposite direction and you annotate the leaves before the root, you'll find as you move up the tree that, oh man, we kind of screwed up in the leaves. We made some bad assumptions and we have to backtrack and keep going back to those leaf libraries and kind of fixing up some things where we had the wrong assumption about nulls. Another way to approach it, if you have like a bigger solution, is focus on the APIs. Go to each one of your libraries, focus on annotating those public APIs and getting them settled, and then later on move to the implementation. That way, your big solution can essentially have good communication between the libraries on what the null state of data is, while the implementations can pick the troublesome parts, the parts they want to focus on for annotations first. And once again, this is the solution we took in Roslyn. We basically went to the compiler, we annotated all of our public APIs first, because that gave the most benefit to the IDE team. And the IDE side of our team could then learn from those annotations, make their code better. And now we kind of have a small side project where we're focused on moving a lot of our core implementations that are not public to also have nullable reference types. Now, my slide deck will be available in my speaker profile. There are a couple links here that basically show some of these kind of different strategies in practice, particularly the .NET SDK and C# compiler one. It's a link to a collection of pull requests that you can look at, which show you annotation strategies in real practice. So lastly, I want to kind of close up talking about like nullability looking forward. So like, where are we going from here with nullability in .NET? So in terms of the .NET ecosystem, as I said, the core libraries are annotated now. Many of the other components of the SDKs like Roslyn, ASP.NET Core, EF, their annotations are all in progress. We all kind of have our plans for how they're going to ship. And we're seeing in the general ecosystem, we're seeing increasing uses of nullability. And we're already seeing like a lot of the core libraries like InUnit, XUnit, and NumSoft, they've all applied nullability. They're pushing that into the distribution channels like NuGet.org. And we're taking them in and starting to get the benefits of consuming those libraries with annotation. So it's very much making its way through the ecosystem and really starting to add a lot of value. So in terms of the language, so C# 8 was the big one, introduced nullable reference types, huge release for us. C# 9, as we've gone over, lots of substantial changes to how we did a lot of the analysis, some new features and attributes. Going forward in C# 10, though, we're going to continue evolving nullable reference types. But these changes are going to start to kind of be more in the margins. This feature is not done by any means. Like I said, we're going to be evolving it for a long time, but we feel like the big building blocks are all in place now. And the work that we see remaining is more kind of in the margins and helping with some of the other patterns that we're starting to learn about that are impacting a number of customers. And so if you kind of look, like we recently did a big triage of all the C# 10 features, and I kind of were breaking them down for this talk as there's a couple of things that have direct impact on nullability. So things like adding additional attributes, going back and adding more enforcement for attributes that we'd add in C#8. Those are like direct, this impacts nullability. But there are a lot that have some indirect impact. And what I mean by that is these are features like extend definite assignment, required properties, parameterless struct constructors. These are features that stand on their own. You could have done these features if we had never done nullable reference types in the compiler. However, as our customers have used nullable reference types, they've kind of been pushing on these features. And they're saying, hey, you know, if you made definite assignment better, or if you gave me required properties, think of how much better my nullable code could be. And so it's kind of given us a little, kind of turned our head a little bit to look at it, like, you know, maybe we should go back and look a little harder at these features and how they could make nullability better. And like one example is like, how can nullability, like, why does that have an intersection with definite assignment? Well, if you think about it, like, this is a piece of code that probably everyone in the room has written. You know, if map try get value, you know, get out this value and then use it. Great. Well, then what a lot of customers came to us and said is, hey, you know what? I turned on nullability checking and it told me that map could be null. And it was right, map could be null, like I had a bug. So the first thing I did was I used the null condition operator, said map, you know, question dot try get value. But then I found out, hey, I started getting an error on the next line because value is not definitely assigned. And this is just, it's a bug from when we did question dot originally in Roslyn, I think in 6.0, where we just didn't extend definite assignment to recognize this operator because we didn't think it had a lot of value. It just wasn't worth the cost. But now nullability is kind of forcing that issue again. People keep pointing this out to us saying, hey, you know, my code could be better if you went and implemented this feature. And so it's definitely something that we're giving a look at. And this particular, the definite assignment change, I believe we're actually going to be going over that in C# language design, and then probably about the next 2 or 3 weeks. We have Ricky Gibson who reports to me. He has a nice proposal written up for it. So really excited to see a lot of these changes kind of start coming to C# 10 so we can make nullability even better. So at the end of my talk, I have a lot of resources for like exploring nullable reference types, a link to the spec that we have written for them, as well as a lot of different tutorials that people have done. And so with that, that's kind of the end of the talk. And so I think we have like a nice Q&A session. But before we start that, I just want to say thank you everyone for coming. Like, this is an area of my life that I've spent an enormous amount of time on, and I am super happy to have you to spend the hour letting me talk to you about it.
Thank you, Jared, very much. We're super happy too. We're listening to you about nullability in C#. It was very interesting and very useful, and we have a bunch of questions.
All right.
Let's begin from the first one. Very interesting question to my mind. Does nullability analysis take JetBrains annotations into account? Could the libraries annotated with JetBrains annotations leverage nullability, or should JetBrains annotations replaced by new attributes by Microsoft?
So we do not recognize the ones by JetBrains. When we were originally doing this feature, we looked a lot at what JetBrains done and a lot of their solutions. And so, but we ultimately chose to kind of, we needed to have the attributes be in the core library so we could use them. So our focus was on recognizing those attributes. I have seen a lot of people who have done like conversions from JetBrains to the new attributes though.
Okay. Is there any tool to convert from JetBrains annotations to Microsoft?
I believe that I want to say that I have seen one out in the wild, but I could not recall it off the top of my head. But I have seen some tools. I thought I even saw some writer demos where people were converting code from kind of JetBrains annotations to the C# ones in Writer. But I cannot recall the name of the tool off the top of my head.
Okay, guys, from the Telegram chat, please let us know that we're answered or not answered on your questions. Well, but now we are going to the next question. Is there a way to restrict generic type parameter to a non-nullable or always nullable type?
So yes, so there's two ways for that. First, you could say there's a constraint we added in C# 8 that I didn't have time to cover called not null. So you can essentially say where T : not null as one word. And that prevents both having you cannot instantiate it with a nullable reference type or a nullable value type. If you want to restrict it to, if you want to allow nullable value types, but not nullable reference types, that one is a little bit harder. You can exclude nullable reference type by saying like where T class, because where T class is essentially saying I want a non-null constraint, where T class question is saying I want a reference type, but it can be nullable or non-nullable.
Okay.
There's no way to. There's no way though to. There's no way to force it though. I believe part of the question said there's a way to force it to be always like a question mark. There's no way to do that. But if that's the kind of situation you have, there are a lot of patterns you can use that it's better in those situations to essentially restrict them to be not null, but then use T question on all of the uses of T within the type, and that will get you the same general flow in that API.
Okay, thanks, Jared. The next question, is there a formal specification of how nullness flow typing works?
Yes, so if you look kind of on the more resources slide, this one down here, I can't really, as soon as I highlight it moves. If you go to the C# lang repo, go to proposal C# 9, nullable reference type specification, that is the one that we are actively working on. So the C# 8 version, we wrote kind of a very loose specification for how it worked because we were basically burning the midnight oil just trying to get the feature to work, and we kind of lost track of specification. Something that we have been doing over the last month, though, is bringing the specification up to date with the state of C# 9 nullable reference types. It is still a work in progress, but if you kind of look at it, like we are kind of updating it on a semi-weekly basis now. We kind of have a small working group within the compiler team where we're basically we're looking at bugs that people file, common sources of confusion, and then we're kind of focusing, updating the spec based on what we perceive to be kind of the highest levels of confusion right now. But that is definitely the place to go and look, and it will be updated with increasing frequency over the next few months.
Great. Did you try the latest version of ReSharper tool? It understands Microsoft annotations pretty well with some teeny bugs.
Yeah, I have not. So I have not used ReSharper recently. I actually use it a lot when I'm testing out like VSVim, but I have not used it recently. However, we are aware that the ReSharper team does do a lot of work with it. Probably the Tessin R, who is also doing some presentations here, he works for JetBrains, and he is he's almost our QA team for Nullable. He has filed some of the best and most insightful bugs on the compiler. And so we're very well aware that they have actually been looking at it and ingesting it. And we're really happy to see that. And we're really happy with all the bugs that they have filed on us to get some of the corner cases in shape.
Okay. What are the most challenging task or decision you faced when adding nullability feature besides ability to support very old code?
I think so. Man, which one do I talk about? There are so many to choose from. I think honestly, one of the biggest problems we had was deciding how to turn it on. We spent endless amount of times basically saying, like, we ended with the two ways of saying have the global switch that turns on nullability for the entire project and the nullable directive. But we spent endless amount of time deciding before we got to that. We had many proposals where you could essentially, we would say that, hey, when you have we would use, you put an attribute on the type for a while, and that's what told you. And then we had to make decisions on, is the default non-null? So if the default's not null, it's actually much easier because you could say things like, well, if I do string bang for non-null and string question for null, then that's how people opt into the code. But for a while, we actually had this method where you essentially would opt in a class. You at a class level, you would say, hey, this type enables kind of nullability. And we were really kind of sold on that in, I believe, kind of the summer and fall of 2018. We were kind of sold on like, this is how it's going to work. But then actually, as we got further into our testing, C# is a really complex language, and you have to deal with a lot of really weird things with like, type substitution and having like subtypes that become type arguments of base types. And we actually found that what we had chosen as kind of the way to turn on nullability was not workable. There were corner places in the language where it was completely ambiguous, and we kind of had to like almost throw out our entire enabling scheme when we were about 2 months from releasing our first kind of like big demo release to people. And we ended up that's where we eventually decided on the nullable enable directive. And big props to my team, because that was a real last minute change, and they really had to burn a lot of late nights to get that checked in for that first demo of nullable reference types, I believe in about January, February of 2019.
Okay. Are null checks retained in the resulting bytecode, machine code?
Yes. So all the null checks you write, because remember, this feature does not impact runtime or semantic behavior. You can put all the questions, like when you put question marks on types or you use the null forgiveness operator, we don't change how the code executes. So if you do a null check, you will see that null check in code. And so that means that we don't erase them. Unless there are times we do erase null checks in C#, but it has nothing to do with nullable reference types.
Okay. Do you consider adding more code flow annotations such as instant handle attribute from the JetBrains ReSharper?
Yes, and that is something like going into C#10, that is the type of thing I really kind of envision us doing, is investing more in kind of annotations that handle more of these scenarios. Like I said, the big investment this time was member not null, and that was actually, on the surface, it looks like a very easy change, but once you get down to how you enforce it, how it works in inheritance, it was actually a pretty complex change to implement. And so these are, but there are plenty of other attributes we were looking at. We were like, if we had more time, we could fix that next level of problems for customers. And so we encourage customers, like, keep sending us your problems, keep sending us the samples up. This is how I used to write my code, and nullable is not helping me here. I feel like an attribute could help connect the dots for me. We love to read about those because we love to have those kind of on our plate for when we have some time, this is the next thing to do.
Okay.
Hey there, here I come. That means actually that we have 1.5 minutes to end the session and to continue in discussion zone. So if you are watching us right now, Jared and Yuri are going to discussion zone, and the link to the Zoom room is in the Telegram chat, which you can find under Jared, under the player, or the direct link is also right there under Jared. So, and at this point, I just wanted to thank you, Jared, and thank you, Yuri, for questions, and Jared for your awesome talk and for your energy. Actually, that was quite like fun to watch, and I actually feel that you are somewhere in the morning. Yeah, because like it's quite late here in St. Petersburg. Thank you, thank you guys, and please proceed to the discussion zone to ask more questions to Jared.
Awesome.
Thank you. Bye.
Thanks so much, everyone, for attending. Really happy to talk to you all today. Thank you.